Hey everyone, in this video we are going to talk about direct proportion and indirect proportion. It is a topic under ratio and proportions, and firstly we are going to look at what is direct proportion. So suppose that there are two quantities related to each other. Let's say we have petrol consumed and distance covered by that vehicle. So the more distance you cover, the more petrol is needed, the more petrol is consumed, right? So if this is the case in which both the quantities increase, that means if one quantity increase, the other quantity has to increase. In such cases, we say that these two quantities are in proportion, in direct proportion. So petrol consumed is directly proportional to the distance covered. Let us take another example now. You have a quantity electric bill and another quantity usage. The more you use electricity, the more electric bill is going to come, right? So again, electric bill is directly proportional to usage. So let us assume that there are two ratios, A is to B and C is to D. So if these ratios are in direct proportion, then we write these as, you already know this, A is to B is proportionate to C is to D. And therefore A by B is equal to C by D. A proportion is nothing but equality of two ratios, right? So whenever ratios are in direct proportion, you write them like this. Now let us solve a problem involving this. We have 3 apples whose cost is 15 rupees. Now what is the cost of 10 apples? Well, here there are two quantities. One is apples and another is cost. And when you increase the number of apples, the cost also increases. This means that this is a direct proportion. Apples, the number of apples are in direct proportion to the cost, right? So I can take the ratio of the apples to its cost is directly proportional to another ratio of apples to its cost. So 3 is to 15. 3 is the number of apples, 15 is the cost, is directly proportional to, now the number of apples is 10, let the cost be x. So I can write 3 by 15 is equals to 10 by x. So therefore x is equals to 10 times 15 by 3. So 10 times 5 is 50. The cost of 10 apples. Let us now talk about indirect proportion, which is also known as inverse proportion. So inverse proportion says that if you have two quantities and if one of the quantity increases, the other decreases. That is, one quantity is inversely proportional to the other quantity. So what could be the examples of such quantities? Well, you have speed and the time taken to complete the journey, right? So when you increase the speed of your car, the time taken to complete the journey decreases, right? More the speed, the less time it will take to reach your destination. So hence I can say that speed is inversely proportional to time. And it is, right? Speed is definitely inversely proportional to time. What could be another example of inverse proportion? Well, if you have number of men and if you have another quantity as the time taken to finish work. So the more the number of men, the less time it will take to finish the work, right? More men will do more work and hence we will finish the work faster. So theoretically, if we take two ratios, if we have A is to B and C is to D, if these are the two ratios and these are inversely proportional, then I can say that A is to B is proportional to inverse of the other ratio. So is proportional to D is to C. So hence A by B is equals to D by C. So you have to keep this in mind. When you have inverse proportion, you invert one of the ratios and equate it with the other, right? When you have direct proportion, then you take the direct proportion of these ratios, right? So this is the main concept behind this. Let us now take a problem that involves inverse proportion. So if 10 men can do some work in 20 hours, how long will it take for 15 men? Now again we have a situation of number of men and the time taken to finish the work, right? So the more the men, the less time it takes to finish the work. So I can take two ratios here. The ratio of men to hours, we have the first ratio as 10 is to 20, and another ratio is of 15 men is to the time it takes for them. So let it be x. But this is in inverse proportion, right? So I can say that 10 is to 20 is in proportion with inverse or the inversion of one of the ratios. So let us invert this. Let us invert 15 is to x. So x is to 15. Therefore 10 by 20 is equals to x by 15. And hence x is equals to 10 into 15 by 20. So I have x's value as 15 by 2. So it takes 15 by 2 hours to complete the work by 15 men, right?